Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 1496, path crossing. Easy level question. Let's get to the description. Given a string path where path is one of four characters, N, S, E, or W, all capital, each representing a movement in one unit, north, south, east, or west, respectively. You start with the origin 0, 0 on a 2D plane and walk on the path specified by path. Return true if path crosses itself at any point, that is, if at any time you're at a location that you've previously visited. Return false otherwise. In my own words, we're given a path, which is just a list of directions of whether to move up, left, down, or to the right. Tell me if the path is crossing itself at any point, meaning that if there's a point on a 2D plane that's been visited more than once, return true. Okay, we have some examples then. North, east, south, we go top, right, bottom, nothing to cross, return false. However, if you were to go north, east, south, west, west, actually a north, east, south, west would be enough to output true because we have visited 0, 0 before. All right, so this is pretty easy. This is probably following a pretty common layout of a problem where there's this structure, usually a set, that represents the visited nodes. It's usually called visited, and it's usually of type set, and it holds nodes or some ID representing a place that you've already been to. In this case, if we were to follow that paradigm, we would have a structure visited of type set that represents the 2D location of on a plane, so via x and a y. And so if we have this set of tuples representing x and y location, we can simply traverse the path and figure out if that location has been already visited. If yes, if that location already exists in that set, then return true, otherwise return false. So then let's begin the implementation. I'm going to have this set, and I already said that I'll be storing the x and the y in it. I'm storing initially the first position in there because that's where I'm starting. Let's have x and y equaling both 0. And now for step and path. Okay, here, let's see. What am I supposed to do here? I'm supposed to figure out what my next x and y are going to be. And I can do that by the following. If step is equal to north, then I'm going to be modifying the y plus equals 1, right? And I can actually follow something similar for the rest. North, and then we have south, which is going to be minus. We have an east, x, and we have a west, which is left. Also along the x-axis, and a minus. Now that we have these outlined, we can make this easier so it doesn't have to check each time. Actually, we can even do this else. There we go. Now let's see if this new x, y is in the visited set. If x, y in, then return true, and then simply visited, add that x, y in there. Let's have the x and the y. and return false otherwise. All right, actually this is pretty much it. Let's see if this works. First try. And I'm already getting something incorrect. Let's see, first step in path. I'm returning false, although I should be returning. Let's see if this works. There's a okay, so I actually might be. Why is this wrong? What am I doing here that is... I think that I should consider printing the visited set to see what is actually being put in there. I presume, my hypothesis is that... I see. There we go. This should work. I guess that when adding a tuple into the set, or initializing it as such, actually assumes that you're just adding both of the individual elements at once. But I want to add the tuple itself as an element in the set, and so that was my mistake. And that's it. That's it. The rest is the same. We're checking if that tuple exists in the visited set. If it does, return true. Otherwise, add that set again. Although this is interesting. How come this works fine, but this doesn't? I don't know. And I think it just has to do with the way that the init constructor is written for set. All right, we have that down. Let's see how we did against the other solutions. Not great. Not great. Let's see why. Let's see what some of the better ones are. Interesting. So some of them removed the need to do if-else statement by having this path be a dictionary itself, and you can access the way you can access the way to move in either direction just by accessing this dictionary. That's great, but I don't really like that. This is good. And this is one-to-one with what we have, pretty much. For deer. This is following the same idea, and they're doing 26 milliseconds. Interesting. Let me resubmit this one more time, see if the runtime decreases at all. It does a little bit, but not significantly. I still think that this is a really good solution, and I saw something that's very similar up on the better percentile. So I would say just stick with this. There are ways to optimize this. Oh, I have a print statement. That's why. That's why it's not working. This is going to be fast. There we go. 38 milliseconds. This is way better. Please use this. This is a very thorough and very easy to read solution, and I would say that this is probably one of the best ones. One of the more intuitive ones and easy to do in an interview. So, alright, with that, let's end it here. Thanks for watching, and I'll see you later. Bye.